Now that we have all of our rules for differentiation in place and all the derivatives of the functions, let's ask ourselves the question, can we differentiate it? I'll give you a function, and then I'll take the derivative. But I encourage you to pause the video after you see the function so that you can try to take the derivative yourself, then check your work against mine once you're done. These will be pretty complicated functions, so we'll need all of our resources to take the derivatives. Let's get started. Here's our first function. I'm given f of x equals natural log of x squared minus 1 all over the sine of 4x minus 5 plus 2. Let's differentiate this function. So if you are going to try to differentiate it yourself, now's a great time to pause the video. So I'm trying to take the derivative of my function f of x. Let's go ahead and use the quotient rule on this problem. Even though I said earlier that the quotient rule is not my favorite, it might be a little less confusing in this case. So the quotient rule says the derivative of this is the bottom function, sine of 4x minus 5 plus 2, times the derivative of the top function. So the derivative of natural log of anything is 1 over that thing times the derivative of the thing by the chain rule minus the top function times the derivative of the bottom function. Well, what's the derivative of the bottom function? I have sine of some stuff, so its derivative is cosine of some stuff times the derivative of the inside stuff. So I have cosine of 4x minus 5 times the derivative of the 4x minus 5, which is 4. We'll squeeze that 4 in there. And then I take the derivative of 2 and I get 0. So I don't need to write it. And this is all over the bottom function squared. 4x minus 5 plus 2 all squared. That's the derivative. So I could clean it up just a little bit, and I will just because we're so squished on this side of the paper here. But if you're taking the derivative, this is your answer. So we have sine of 4x minus 5 plus 2 multiplied by 2x over x squared minus 1 minus the natural log of x squared minus 1 times cosine of 4x minus 5 times 4 all over sine of 4x minus 5 plus 2 squared. That's derivative. The second function that we want to differentiate is f of x equals e to the power cosecant squared natural log x minus 2. Remember that natural log and log are the same thing in all of our videos. Also, remember that cosecant squared of x is the same thing as taking the cosecant function and squaring the whole thing. So I take the derivative of this function. Well, I'm going to have to use the chain rule a whole bunch of times. So the outside function is e to the x, and the derivative of e to the x is just e to the x. So I have e to the cosecant squared of natural log of x minus 2. Now I have to multiply that by the chain rule by the derivative of this exponent. So the next thing that I have is cosecant of some stuff, and that's being squared. So the next derivative is of the squaring function, and the derivative of squaring is 2 times that function to the first power, so I don't actually need to write it, cosecant of natural log of x minus 2. All right, so I move to the next innermost function, and that's the cosecant. So the derivative of cosecant is negative cosecant cotangent, so I multiply by, we're going to move to the next line since we have so much stuff. So I multiply by negative cosecant of the thing, natural log of x minus 2, times cotangent of the same thing, natural log of x minus 2, for the derivative of the cosecant. Now I have to move to the next inmost function, which is natural log of x minus 2, and the derivative of natural log of x is 1 over x, and the derivative of minus 2 is 0. So again, I could clean this up a little bit just because it looks a little strange on 2 lines. We'll have to write it a little smaller to try to get it to fit, but this is the derivative that we want. So move the 2 to the front because it's a coefficient here. I have 2e to the cosecant squared natural log of x minus 2 times cosecant of natural log of x minus 2 times negative cosecant of natural log of x minus 2. Could combine those if you really want. Cotangent of natural log of x minus 2 times 1 over x. And that's my derivative. For our third example, let's consider the function f of x equals the cotangent of 2x all to the third power minus the natural log or log of 4x squared plus 3 all to the fourth power. So this natural log of everything is being raised to the fourth power in this function. All right, let's take the derivative. So the derivative of my function f of x is equal to, well, here I have the sum of two functions, so I can take their derivatives separately and add them together. So in this first function, I have the cotangent of some stuff and it's being cubed, so that's my outermost function. Derivative of the cubing function is 3 times the stuff to the second power. So I have 3 times cotangent of 2x to the second power times the derivative of the inside stuff. Well, the derivative of the cotangent is negative cosecant squared. So I have negative cosecant squared of 2x. And then, so that's the derivative of the cotangent function. And then moving inward to the next innermost function, that's 2x. And so I take the derivative of that and I get 2. So this is the derivative of this first piece of the function. The second piece, we'll put it down here on the second line. So the outermost function here is the fourth power function, so that's 4 times natural log of 4x squared plus 3 to the third power. Moving to the next innermost function, that's the natural log. So the derivative of natural log is 1 over 4x squared plus 3. So natural log of stuff has derivative 1 over stuff. And then moving to the next innermost function, I multiply by the derivative of 4x squared plus 3, and that is 8x. So that's the derivative in this case. Again, we could clean it up a little, but this one's not too hard to read. For our last example, let's consider the function f of x is equal to x to the power sine x squared times cosine squared of x. The first thing to notice is that these two functions are very different. Here, the squaring is happening on the x variable inside the sine, and here the squaring is happening on all of the cosine of x. So remember that cosine squared of x is the same thing as cosine x all squared. All right, so let's take the derivative of this function. The best way to do this is actually to use implicit differentiation. So we'll get a little practice with that. Let's write y is equal to x to the power sine x squared cosine squared of x. And then since all of the interesting things here are in the exponent of an x function, what I want to do is get it down from the exponent. That would make everything easier for me. And then I go ahead and, in order to do that, I'm going to take the log of both sides. So log, natural log, same thing. Natural log of y is equal to the natural log of x to the power sine of x squared cosine squared of x. And so now, because this is the log of x to some exponent, the exponent can jump down on the outside of the log. So I have the natural log of y is equal to the sine of x squared times the cosine squared of x times the natural log of x. And now I can take the derivative of both sides. So derivative of both sides, remembering to use a chain rule because this is implicit differentiation. So here I have the derivative of the natural log of y is 1 over y times the derivative of y, which is dy dx, by the chain rule. And on this side, I'm going to need to use the product rule for 3 functions. So you can work that out on your own, or you can believe me when I say that I take the derivative of the first one times the second 2, plus the derivative of the second one times the first and the third, plus the derivative of the third function times the first and the second. So I have the derivative of sine x squared. Well, the derivative of sine is cosine. So cosine x squared times the derivative of the innermost function, which is 2x. So this is the derivative of my first piece of the function. And then I multiply by the other two functions, cosine squared of x times the natural log of x. So that's the first piece of my derivative. Plus the second piece of my derivative, I leave the sine x squared and the natural log alone. So sine x squared, I take the derivative of cosine squared of x, remembering that this is cosine of x all squared. So this is 2 times the cosine of x to the first power, so I don't need to write that, times the derivative of the inside function. So the outside function was a squaring function. The inside function in this case is a cosine, so its derivative is minus sine of x times the last function, which is natural log of x. Finally, we take the derivative of the natural log function, leaving the first two functions alone. So plus sine of x squared cosine squared of x times the derivative of natural log of x, which is 1 over x. So now, this is the derivative of this product of three functions, and I want to solve for dy dx. Not too bad in this case, I just multiply both sides by y. So I have that dy dx is equal to y times all that other stuff. So cosine of x squared times 2x times cosine squared of x times natural log of x plus sine of x squared, 2 times cosine of x times minus sine of x times natural log of x plus the sine of x squared cosine squared of x times 1 over x. But we know what y is from our original function. Y is equal to x times x to the power sine x squared cosine squared of x. So now we can go ahead and put that in. So y is equal to x to the power sine of x squared cosine squared of x. And then we multiply by, again, all of this derivatives. So we'll rearrange just a little bit. We'll put the 2x first in this first term, and then we have cosine of x squared cosine squared of x and natural log of x. In the second function, I have a coefficient of 2 and a negative 1, so I have minus 2 sine of x squared cosine of x sine of x natural log of x. And then in this last term, I just have sine of x squared cosine squared of x and 1 over x. Like so. So here's our derivative of the last function. That was fun. And I hope it's built your confidence a little bit on taking the derivative, and as well as shown you how many different types of functions that we can now differentiate. Keep working on taking the derivative, keep working on your practice problems, and good luck.